Hello, my name is Elizabeth, and this is Amanda.
Boy.
Show yourself. And this is our low pass filter circuit. So here we have the input and channel 1 connected, channel 1 of our digital and connected to the input. This connects to the resistors, which are in parallel. And so to combine, they form an equivalence resistance of 1.5 kiloohms. Then that connects to the capacitor, which has a value of 0.001 microfarads. And so here, channel 2 of the digital is connected to the output of our circuit. And here on waveform, we see what the results are. So yellow represents channel 1, and channel 2 is blue, which is the output of the circuit.
So this graph represents the ratio of the output to the input, and this represents the frequency response. This graph shows that at lower frequencies, the circuit allows the frequency to pass, but at higher frequencies, the ratio goes down. It also shows that at lower frequencies, the phase doesn't change, but at higher frequencies, the phase response changes. So this is our band pass filter. This resistor is connected to these two components. This is a capacitor, which is 0.001 microfarads, and this is the inductor, which is 3.3 millihenries. And these two components are in parallel with each other. This is channel 1 and this is channel 2, which is the output of our circuit.
And so right now, the output is being measured across the inductor. So if we perform our sweep here, we will see the response. And so when we measure the output across the inductor, we see that at this value right here, at this frequency, is where our gain is the highest. And so lower frequencies have a lower gain, and so here we have its value closest to 0, and then here that aligns with the inflection point of the phase. And so if we change channel 2 to now measure across the capacitor, we will see the response of the bandpass filter across the capacitor. And so I'm going to run it again.
To create a plot with the theoretical equation. And
we see that at this frequency, at 87.6 kilohertz, is where the gain is at the highest, and here is also the response from our phase. And so channel 1 is represented by the yellow line, and channel 2, the output, is represented by the blue line.